Alright, now moving with the second video of this chapter, triangles. Today we will be discussing very important theorem which is asked many time in exam, which is basic proportionality theorem, BPT theorem or Thales theorem. Okay, there are two ways it can be asked. Now before I go with the theorem, before we go with the theorem, you have to understand one concept. For example, this is a line. Okay, this is a triangle, and let's say this is also a line, and this is a one more line here. This is parallel to each other. Okay, these two lines are there. For example, the triangle ABC and PQR, the two triangles. Okay, ABC and PQ are two triangles. If I say AM is perpendicular to this line L. AM is perpendicular to this line L. So for this triangle, the area of triangle is half, base is BC, and height is what? AM. Area of this triangle is half base into height. So can I say BC into AM? Similarly, in this triangle also, the area of triangle PQR, area of PQR is what? Half, base is QR, and if you observe, height is not, there is no perpendicular line. I cannot say PQ is height or PR is height. Can I say AM is also a height for the same? Half base into height, because this height and this height will be same. So it is what? Whenever perpendicular line is drawn in the same line, wherever perpendicular line is drawn, height will be same for all. Okay, so this 90 degree will be height for both the triangles. So this is also height, this is also height for this. So for QR, this PQR triangle, base is this and AM will be height, because you cannot take PQ and PR because it is not perpendicular. Because if you have learned in the lower class, perpendicular or we can say perpendicular is always taken as height. For example, you have a board. If you want to measure the size of the board, you will measure from year to year? No. Obviously, you will measure from year to year. It is what? Perpendicular distance. Perpendicular distance is height of the board. Or if it is what is the height of the board, you will measure from year to year for measuring the height. For this also it will be year to year. So height is always perpendicular distance. So the fundamental concept is, in short, I am telling, it is only that height is what? Perpendicular distance. Wherever we observe it is perpendicular, it is known as height of the figure. Okay, so now moving with the theorem, which is Thales theorem, or we can say BPT theorem, basic proportionality theorem, or it is also known as Thales theorem. It is also known as Thales theorem or basic proportionality theorem, or it is asked in three ways. It can be asked this way or in this way, that state and prove basic proportionality theorem, and it can be asked state and prove Thales theorem, or they will give the statement only. They will give this question: if a line drawn parallel to one side of a triangle to intersect the another side of the triangle, this is the statement of BPT. Okay, if it is asked state and prove, so this is the statement of BPT. If a line is drawn parallel to one side of a triangle to intersect the other side of the triangle at a distinct point, the other two sides are divided in the same ratio. So this is very important statement. With the help of this statement, you will do many questions. So it says there's a triangle, and what it says, let me explain you. It says there's a triangle. If a line is drawn parallel to one side of a triangle, if I'm drawing a line parallel to one side, this is parallel to this. Okay, can I say this is parallel? Okay, if I'm drawing a line parallel to this, let's say this point is P and this point is Q, then these two will be in same ratio. So whenever a line is drawn parallel to the base, they will divide in same ratio. It means given PQ is parallel to BC. This is given in question, and you have to prove that they are proportional. It means AP upon PB is equal to AQ upon QC. So whenever in any triangle, whenever you observe it, it is parallel, the remaining sides will be proportional. This you have to prove. AP upon PB should be equal to AQ upon QC. This you have to prove. So how you will prove it? So this is, first step is construction. Construction, because a triangle is there. So if you have to solve, so we will be constructing height. For this line I will construct a height from here. Let's say from here. This is perpendicular distance, right? For AB, I am drawing a perpendicular line and stopping here. This MQ is perpendicular. MQ is perpendicular to AB, or we can say QM is perpendicular to AB, and one more perpendicular line from here, or else let's say in the second part, or let it be in second part also it is possible. So right here, and PN is perpendicular to AC. Okay, two things we did. I've drawn perpendicular line here and here. First this line perpendicular and this line perpendicular I've drawn. Okay, now to start the sum, we'll start with to get this part first. How to get this answer first and this answer first, and then by merging you will get the answer. Okay, I'll first solve this. Area of APQ upon area of, and also we join this two lines. So you can say, right, in construction, join PC and QB. So we have done construction joining, okay, PC and QB. So area of APQ and area of PBQ. Area of PBQ. I have taken this triangle, the left side, this triangle and the left side of the triangle, PBQ, this side. This I have taken. This two triangle I have taken in this figure. Okay. So in this triangle and this triangle, first part I will take this, and in second part I will take APQ again common, and this triangle, right triangle I will take. So in two parts it will be done. First this triangle and left triangle, and this triangle and the right triangle. So APQ will be taken in both the part. APQ will be taken first part also, and second part also the same triangle will be taken. Okay. So this is APQ. If you find APQ is what? If you want to find area of APQ, what is area of APQ? Half into base into height, right? Half into base into height. Formula of triangle. Similarly, area of ABC is what? Half into base into height. If you are not writing this step, directly writing the base and height, just for understanding I have written it. So half. Base is what? What is base of APQ? For APQ, what will be base? See, understand, base will be considered wherever perpendicular is drawn. So for APQ triangle, where is perpendicular? Here is perpendicular. So I can say AP is perpendicular, APQ triangle, AP is base. AP is base, and what is height? In APQ, what is height? 90 degrees over here. So height is MQ. Okay. Similarly here also, in triangle PBQ, what is base? In this line, PB is base. As I have explained you in the previous example, for these two triangles, see, this is the example which I have explained. For both the triangles, same height will be common only. Okay. So for this triangle also, MQ will be height. So here PB will be base. For PBQ, PB will be base and height will be MQ. So both will have same height. If perpendicular is drawn to the same line, the height will be same. So MQ cut, half cut. So I got area of APQ upon area of PBQ as AP upon PB. If you observe, I got the first part by doing this. I got AP upon PB. Okay. And the second part, I will take this triangle and the right triangle. Okay. So let us see what I am doing. Area of triangle APQ, again same triangle you have to take. APQ again. Okay. Here also you have taken APQ. Now earlier you have taken the left side. Now you will take the right side of the triangle. PQC. So area of PQC. Okay. Now in this triangle, here also half. What is APQ base now? Now I have moved this side because I have taken the right triangle now. So base will be AQ because 90 degrees here now. AQ into height is now taken PN. Okay. Similarly, for this PQC also half. Now in PQC, what will be base? QC will be base. As I said, the same line perpendicular, only one perpendicular. So this will be perpendicular. So PN will be the height. So half base into height. So this is only the concept you have to understand in the whole, or we can say whole theorem. You have to just concentrate that this height should get cut. So you will get the correct answer. So it is AQ upon QC, here also AQ upon QC. So it is area of APQ upon area of PQC. I got the answer as AQ upon QC. This is equation 2, and let's say this is equation 1. Now can I say these two are also equal? Can I conclude, are they equal? We can say no, because this is APQ upon ABQ is this answer, AP upon PB, and APQ upon PQC answer is AQ upon QC. The numerator is same, but the denominator is different. So we will make the denominator also equal, which is triangle PBQ and triangle PQC. They are not same because the numerator is same. If the denominator is same, then I can say this two also will be same, which will get the answer. So only thing we have to do is, if you are able to make the denominator same, then we can say AP upon PB will be also equal to AQ upon QC. Then we will get the answer. So first we will make the denominator same. If you observe PBQ and PQC, PBQ, this is the same base, right? In PBQ also PQ is base. In PBQ, PQ is base, and in PQC also PQ is base. PQC also PQ is there, and PBQ also PQ is there. So if both have same base. If you have remember in 9th standard area parallelogram chapter, we have discussed this concept. So PBQ and PQC have same base. What is same base? PQ, same base PQ, and lie between same parallel lines. Lie between same parallel lines. Therefore, area of PBQ will be equal to area of PQC. So we have got the answer now, because we have made this base also equal. These two also are equal. PBQ equal to PQC. So by equating by equating 1, 2 and 3, we can say our answer is AP upon PB will be equal to AQ upon QC. Very important theorem. Just see the format how it should be done. What we did in the beginning, first we have drawn the triangle, we have constructed these two perpendicular lines, joined PC and QB. In first part taken APQ upon this left triangle, in second triangle taken APQ upon the right triangle. So APQ common and PBQ taken. First triangle we have taken triangle and left side, and again the triangle right side. This is the way, and we have solved accordingly while with taking height same. So the heights get cut. So very important. Then to make the answer, to make this two equal, we have taken the base same with the property. They have same base and same parallel lines property. The area will be also equal. That property we have used, and we have got the answer. So this is what BPT theorem. Okay, and BPT theorem corollary also there. Corollary means with the help of this theorem, few more statements are also proved, which is, if it is this, for example, what is BPT theorem? If PQ is parallel to BC, this is the theorem. If PQ is parallel to BT, then what is our answer? It is AP upon PB will be equal to AQ upon QC. This is we have learned in BPT theorem. If this is parallel, then this will be proportional. AP upon P will be AQ upon EC. But also with this, with the help of the proof, with the help of same statement, you can also prove, which is not important, but I will just explain what it is. It is AP upon AB will be also equal to AQ upon AC. This also will be equal, means small part upon AB, means AP upon AB will be also equal to AQ upon AC. This is also true. Also, PB upon AB and QC upon AC will be also true. So with the help of this one proof, this two corollary you have. Corollary means with the help of this statement only we got the answer. Just by adding +1 on both the sides. It is very easy proof. By if you add +1, you will get the same answer. Okay. If you want to understand the proof, we'll discuss in online session. but this proof also can be done. How this is possible? This one can be proved. So this is also true. If PQ parallel to BC, this three all statement will be correct. If PQ is parallel to BC, this three will be correct. First is general, and second is AB upon whole, AQ upon whole. Then it is PB upon whole and QC upon whole. This is only the very easy concept which can be helpful for solving sums. So this is the concept. And now the second theorem is theorem 2, which is converse of BPT. Theorem 2 is converse BPT. Now converse BPT is we can say the opposite thing. If ABC is a triangle and PQ is the line, in this it is what given will be, they are proportional. AP upon PB equal to AQ upon AC. Now it will be inverse. If this is there, then we can say to prove PQ will be parallel to BC. This will be also true. So if this is there, this will be also true. So the proof is also very easy, but it's not important for exam point of view. How we can prove? We have to prove PQ parallel to BC. So we will suppose by contradiction method. Let PQ is not parallel, any other thing is parallel. Let PN is parallel to BC. I suppose that N is parallel. Something will be parallel to BC. If PQ is not parallel, any other line will be parallel to this, because the property we have learned in 9th standard Euclid, one line will be at least parallel to at least one line, right? We can draw at least one line. I can draw parallel to any line, right? So BC will be parallel to at least, if it is not parallel to PQ, it will be parallel to any other line. It can be parallel to PN. We'll suppose that it is parallel to PN. So in construction, you can write PN parallel to BC. Okay. PN parallel to BC. If PN is parallel to BC, right now we have learned by BPT theorem. Right now we have learned if anything is parallel, they will be proportional. So just think, if PN is BC is parallel, we can say AP upon PB will be equal to AN upon NC, right? AB upon PB will be equal to AN upon NC. Right now we have learned anything which is parallel, they will be proportional. If this is parallel, again this upon this is equal to this upon this, right? If this is the triangle, if this is parallel to this, so this upon this will be this upon this. Similarly, these two lines are parallel now. If these two lines are parallel, I can say this upon this will be equal to this small part upon whole part, right? So AB upon P will be equal to AN upon NC. Now if you already, it is given in question that AP upon PB is what? AP upon AQ upon QC. So I'll write AQ upon QC from the question. I've just substituted the value of AP upon PB, which is AQ upon QC. Now if I observe, if I add +1 on both the side, okay, if I add +1 on both the side, what I got? Can I add +1? It will not make change, right? Adding same thing on both the side will, adding equals to equal, the answer will be again equal, Euclid postulate, right? Equals are added, 2 equals, they are still equal. So I'm adding 1 on both the side. Why I'm adding? So that I will get the conclusion. Whenever you are not getting any answer in proportionality, this is the logic of doing adding on both the side. So what I'll get if I take LCM, I'll get AQ plus QC upon QC is equal to AN plus NC upon NC. What is AQ plus QC? Check. AQ plus QC will be, what is AQ plus QC? It will be AC. So I am writing over here, space is less. AQ plus QC will be AC upon NQC as it is. Similarly, what is AN plus NC? Check. AN plus NC will be also AC, and here it is NC as it is. And we say this will be AC cut with the help by cross multiplying. NC is equal to QC. Now is it possible NC and QC will be same size? Can be possible. NC is also 5 cm and QC also 5 cm. Can it be possible to have same size? No. Therefore we can say contradiction to our statement, which is not possible for anything. A large part cannot be equal to a small part, right? So directly we can conclude there is no other point. Therefore PQ is only parallel to BC. There is no other point N which is parallel to BC. So this is the theorem 2, which is only very fundamental. It is not asked, the proof is not asked in exam point of view, but still you should know how it is. Similar to this corollary, also the proof is same way you can prove this corollary by the same method. Okay, all right, so now we will be discussing the next exercise, which is 6.2, in the next video.